Hello, everyone. Let's continue talking. Chapter 24. We're dealing with the Halliday and Resnick book, 10th edition. Chapter 24, electric potential. We're going to look at problem number 33. Problem number 33. The thin plastic rod shown in the figure, and they give a number there, but that's not really associated with what we're doing. There's figure 24-47. So the thin plastic rod shown in figure 24-47 has length capital L equals 12 centimeters and a non-uniform linear charge density lambda equals Cx, where C equals 28.9 picocoulombs per square meter, with V potential equals, with V equals 0 at infinity, and the electric potential, and they want us to find the electric potential at point P on the axis at a distance small d equals 3 centimeters from one end. Okay, it's a little potentially confusing how a question like this can be asked, but there's really no better way to say it in this classic textbook, in this great textbook, than the way they basically said it. It's a very succinct way of saying something. Let's just make sure we know what they're trying to say here. We are looking at this data right here, the linear charge density. So the more we go, we got to assume this is 0 right here. X equals 0 right here, you guys. It's not really said explicitly, but it's understood. And right here, then, the X would be equal to L. So not explicitly said, but definitely, I think it's something that's definitely understood. So what do we have to say, guys? The more you go along the x-axis, the greater the linear charge density. Okay? We could go as far as L tells us to go. So we know what L is, capital L that is, right? And we know that V equals 0 at infinity. So in other words, I think what they're trying to say here is if you took this guy, this point, and went over to infinity, very, very far away, the potential is very, very small. And the further away you go, the closer that it approaches 0 as you go toward infinity, is what they're telling us. So let's see what they're trying to say here, guys, what we can say about some of the stuff that is present here. We repeat, lambda is equal to Cx. That means dq dx, charge divided by distance would be lambda, and that's equal to Cx. That means if you multiply by dx on each side, dq equals Cx dx. Very important conclusion. Well, that's going to drive a lot of what we need to do. Potential, based on things that we've already discussed in the past, in other videos, and what we know from the book, the potential is going to be kq over r. Integration done in the right manner, within the appropriate limits. kq over r, well, k is 1 over 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught is k. We got this. This is dq over r. We just got to get the right limits of integration done to actually get this thing under control. What is there to say? Well, I mean, there's a good amount to be said. Let's just keep saying it, I guess you could say. We got 1 over 4 pi epsilon naught integral. I'll get the right limits of integration when the time comes. dq is Cx dx. Okay, correct. And the r is the distance away. Well, as x proceeds from x equals 0 all the way to x equals capital L, that's the distance, kind of, because don't forget, you got to have the d there as well. D plus whatever value of x you have, well, in this case, x equals 0, d plus 0 is d. D from here to here is d, from here to, so from here to here is d, from here to here is L. That distance from way over there to here is d plus capital L. From here, that distance is just d. So d to d plus capital L. Well, how's this working here? The moral to the story is the d has always got to be present, and whatever x you add to it, that's what you're talking about. So basically what we're going to say here is we got, looking at this real carefully, that c can come out of there. And we got v equals c over 4 pi epsilon naught times the integral. And again, now look, I mean, since we've already put the x in there, see, we didn't start the x right here at, if you were going to call that yours, well, you can't really call it that. There's other ways you could have written this, but for our purposes, here's x equals 0, here's x equals capital L. Everybody is, whatever distance this says from x equals 0 plus d will give you what P1 is. So there's a lot of things to go. Let me still stay without putting the limits of integration on there. I pulled a c out of here. Right, look at something like that. So a whole lot you can say here. Well, we got true, absolutely true. All right, guys, let me leave a lot up here, and then let me leave much of this up here, but then much of the other stuff I'm going to take off here, and let's just smoothly proceed and see what we're going to do. We essentially have the whole game plan completed. We know what we need to do. We wrote what we need to do. That thing in yellow is what you're going to end up doing. There's a lot of ways to play this and get out of the woods with this. I mean, the first thing that kind of jumps to mind when I'm looking at something like this is, can I simplify this somehow? Well, it's not an easy thing to simplify, and yet maybe it is in some regards. If this is x over all this, couldn't you add a d to this and then subtract the d? It's like, well, yeah, what are you really accomplishing? Well, x plus d is the same as d plus x. They cancel, you got 1, then you got minus d over all this, and maybe something can be done. Let's take a look at it. I mean, this stuff is, I think, basically easier done than said. Let's actually work with it. Let me just say something. I mean, you tell me how you feel about it. I mean, let's, guess a lot of ways to kind of look at it. Well, we said it was x, right? Yeah, there's x. Well, leave it as x. But I'll tell you what. Let me add d to that x and then subtract d. And see how that would play out. Is that the same thing? What's d minus d? D minus d is 0, the x stays, and you got this. What's going on here? What did we just do? Well, if you make a move like that, should make a lot of sense. And like I said, we'll deal with that as we deal with it. The big thing here is, since we've already had the d on the bottom, we are going to go from x equals 0 to x equals L. Kind of cut to the chase on that one, guys. We're going to go here. I know I said this d plus x business, this d plus L business. Yeah, that's all well and good. The d's already in there. It's accounted for. So go from the x values varying from x equals 0 to x equals L. Okay, well, it's looking pretty good. I think that's the hardest part of the problem, you guys. From here, I think we can look at it and get the whole thing under control. We're saying, okay, v is equal to c over 4 pi epsilon naught. And here goes. This goes into here one time. This goes into here, d over the quantity d plus x. So what's going on here? And the integral of a sum is the sum of the integrals. The integral of the difference is the difference of the integrals. Pretty neat stuff that way. Here goes. From 0 to L. In the notes, I didn't do it in kind of until the end. What the heck? It's a horse apiece, you guys. You go like this, and you got x plus d over x plus d. All right, we already talked about that. Dx minus the integral from 0 to L of d over x plus d dx. It's kind of the essence of the whole problem, you guys. You got to, once you get to here, you're doing pretty good. Once you get to here, you're doing pretty good. So, look, this divided by the same this, the quantity x plus d divided by the quantity x plus d is 1. The integral from 0 to L of 1 dx is x, evaluated between those two limits. And we'll do all those limitation processes. We'll go between the two limits soon. What's the integral here? It's a pretty interesting problem. The integral with respect to x of 1 over x is natural logarithm of x plus, plus a constant and all that other stuff. Well, look, let's get down to business, guys. Forget the d, it's a constant. D's a constant. Pretend it's a 1. What's 1 over x? What's the integral of 1 over x dx? It's ln x. The integral of d over x plus d, the integral of d over the quantity x plus d dx, this right here, it really becomes d times the integral of 1 over u du. The x plus d, the dx associated with x plus d, if u were equal to x plus d, du dx is equal to 1. The d is not really playing a role. But you still got to give the answer in the end the right way. Make a long story short, you guys. What happens is, and like I said, I've written this a number of different ways here. You can write the d right here, then ln, and we can talk about a lot of stuff actually, but let's just stop right there. And I wrote it a little differently in my notes. So you got that. Yeah, and there's a number of ways this can get written, guys. And I guess I jumped the gun a little bit. I jumped the gun right to here, and that's okay too. It's a little slower in the notes the way I present it. Whatever. I mean, you should be fine, guys. The notes are a little bit more methodical, a little slower, but we did get to there, and that's a real big conclusion for us to get to. So let's see what we can say regarding this. So you look at it, you play the game with this, and we'll see what it says. It's the hardest part of the whole problem, guys. This is the hardest part of the whole problem, and now it's done. You're looking at it. So, okay, look, I mean, let's say a few things. I could say, let's say a few things again, because we already kind of seen this at this point, but let's just go there. That first integral got us x, that second integral got us d times ln of x plus d. From 0 to L. I hope I did not put just x there. If I did, I was wrong. It should be this, x plus d. I think it's, we can see it on the film, but here it is. And the notes are certainly correct, and this is certainly correct, so we're fine. You get to here, do the evaluation, guys. You know, plug in an L and deal with it. Plug in a 0 and deal with it. So what do you got? Well, the big L. With the big L in there, we got this. True. Minus the 0. Put a 0 in here. That's 0. It's not really going to play a role. Put a 0 right here. So there it is, guys. What does this mean? Well, you know, minus and 0 doesn't amount to much. Minus a minus is plus. Here's the L. So what we got here is you got the big L minus 0. That's just the big L. You got the minus thing here, which is plus a negative. This is minus plus a negative this, which is plus a positive this. It's d ln d. This is minus d ln minus d. So, gotta be careful. Just be careful. It shouldn't be too bad, but minus a minus is plus. This minus stayed. D ln right. Usually with problems like this, so oftentimes when there's pluses and minuses, you know, minuses all over the place, plus the opposite is good. Convert everything into addition is probably a better way to go. Probably an easier way to go and do stuff like that. Plus the opposite, you know, plus a negative 1 times that. Minus this is plus a negative 1 times all this. Minus this is plus a negative 1 times this. Minus this is, you know, plus a negative 1 times this. Well, yeah, negative 1 times negative 1 is positive. Then you just got d ln d. As you do this, guys, we've got, and let me make this another parenthesis here, guys. So parentheses and parentheses. Sure, this thing is, the parentheses all match up here, I guess you could say. Was it already there, or let me just think here, guys. I'm not going to nickel and dime this too much with you, but let's make sure we got it. And then this was just this guy right here. Okay. What's going on here, guys? What we have is minus this. Man, there's a lot of ways you could go with this one. Let me just see how I went. Pull the D out of here, and then it's pull the D out of there, then it's just LND minus LN. It's looking like that. The difference of two logarithms is the logarithm of the ratio, the appropriate ratio taken under consideration. The difference of two logarithms is the logarithm of the appropriate ratio. Here's the appropriate ratio, guys. It's looking like that. So there's a whole slew of ways we can go here, guys. You can take the minus here and go plus a negative d. You could take, plus a negative d, which is negative 1 times d, and you can put a negative 1 right here and just leave it like this. Okay, have we changed anything? What's negative 1 times d? It's negative 1 times d is negative d, plus a negative d is the same as minus d, all this stuff. Plus a negative 1 times, negative 1 times d is negative d, plus a negative d times ln d over the quantity capital L plus d is the same as minus d times ln d over the quantity capital L plus d. So not a big deal. What's going on here? Why do you do that? Well, multiply this by a negative 1 is the same as putting negative 1 right here. And this quantity to the negative 1 is flipping this upside down. So ln of this to the negative 1 is ln of this flipped upside down. All this to the negative 1 is just all right, it's a bit of a mess, but it worked. Now saying, why would they do that? Well, it's a little easier to deal with sometimes if you got something like this, because D goes into L, but D also goes into D. And let's see how that all plays out. What do we got? Well, we got C over 4 pi epsilon naught L plus And there's a lot you can do with the D. You could have put the D in, you could have brought the D up here as an exponent. What good is that? You know what I mean? It's probably more easy to deal with where it is. But certainly from the laws of logarithms, you can take, there's those three major laws that we talk about. You make the moves, you should be okay. ln of all this. Now what's going on here? Well, D goes into here. A lot of ways to go, I guess. Let's reverse the order a little bit. D goes into D one time. Just going to try to report it consistent with how I see the key doing it. That's it. I mean, that's the big one here, guys. You get to here. Just make sure we're on the mark here, guys. For some reason, I'm starting to kind of argue with my own notes here. Yeah, this should be the way it goes. Yeah, I'm starting to kind of disagree with my own notes here, guys, a little bit. Let me make sure everything is okay here. Some reason I had put a minus there, so please ignore that. This should be the way that it is. Or maybe it isn't. Let me just to play it safe. Let me make sure I am agreeing with what I have said. I mean, the lion's share of what I'm saying, the lion's share of what I've said up to this point is certainly mathematically sound. Let me just go back because I think I got a feeling somewhere I made a mistake, either just now in the presentation or in my notes. I got a feeling my notes are right, and I simply just did something careless here. Without having the virtue of being able to see the film where I kind of made the move. Let's kind of go at it one more time, please. I'll go maybe a little faster when I do it as well. I'll leave the limits out of there. I'll get into the limits a little bit later. We did say V equals 1 over 4 pi epsilon naught Q over R like that, 1 over 4 pi epsilon naught. The dq is Cx dx over D plus X. Okay, so far we've done all of that. We did all of that. We took the C out of there. And we got to here. And then we had this. I'm leaving the limits out of there. And that's the way I had it in the notes. This real specific limits in the notes. And maybe that was a really good idea back then. And that's D right here. We said everything's in conformity with what we said. I think I got a strong feeling somewhere. I for sure made a mistake somewhere here. Either it's in the notes, which I tend to think I did not, or in the presentation earlier of a few minutes ago. I got a feeling it's in the presentation. We're going to straighten that out right now in a couple minutes. Okay, look at this right here, guys. We're going to make this C over 4 pi epsilon naught, like that. X is the same as d plus x minus d. And this is d plus x. And the whole thing's going to be dx. And of course, I ran out of room. Put the dx right here. That's going to be this guy. So that's going to be everything we've said. Somewhere a very careless mistake occurred, I think. Actually, I know somewhere a very careless mistake occurred. So we have this. This goes into here once. This goes into here, as we've said. Okay. So everything is the same, guys. Somewhere I've got to see what just happened here. Okay. We've got C over 4 pi epsilon naught. Integral 1 minus d over d plus x 1, yes, right, dx that right there can be played a number of ways. And here's somewhere here it must have happened, guys. Let me stay there. Let me not play too many games here. C over 4 pi epsilon naught integral 1 minus, is d the same as, is d the same as d plus x minus x. D plus x minus x, d plus x minus x is d. D plus x minus x is d. Okay, let's see where we are. Let us indeed see, guys. D minus d is x. Okay. Trying to see exactly where we want to go here. We could have done it like that. Okay, that's yet another way to look at it. Yeah, that's an invitation. I mean, this actually will work, but you end up going in circles, and you come back to where you need to go anyway. It's just a little lengthier process. Tell you what I'm going to do. Let me not go there. But let me instead do this integral. Do a lot of the same arguments I did earlier, but let's see what the heck it is. That's going to be equal to v equals c over 4 pi epsilon naught. You end up getting x right here. You end up getting you know, you're going to do the appropriate limits of integration. I'm not quite there yet to do that. It's about where we're at, though, guys. I mean, you get to here. From 0 to L, and see how it plays out. So you've got all these, you've got where it is in the notes, you guys. Let me erase some of this. Plug in the appropriate limits that we talked about. We'll see what we can say. Let's just be careful. I mean, got a feeling I'm going to come back to where I need to go. I wouldn't be surprised if I was right all along, and then somewhere the notes are wrong, and that's on me. Capital L, capital L, capital L, and you know. And all that minus 0 minus d ln d. Just make sure we got this straight, guys. Yeah, it looks pretty good. Looks all right. Put a capital L in there. Put a capital L in there, capital L, then put a 0 in there. It's looking pretty good. You've got L plus L minus 0, capital L minus 0. Capital L minus 0 is capital L. Then you got D minus a minus, D ln D, minus D ln Okay, so what we have here, yeah, I mean, somewhere I made a careless mistake. Now I'm just going to pinpoint where it was, and we're not given the final answer here until we're done. We're on the right track at least. This is going to get us to the appropriate content. You've got L plus this minus that, minus a minus. Let's just see here, guys. It looks straight up like it's right. I mean, it looks like somewhere, you know, obviously somewhere I made the mistake, but I'm just trying to make sure I can pinpoint where. This looks like it's okay. All this logic, I just want to make sure I'm okay. Yeah, it's got to be this if you're playing the game here. If x is equal to d plus x minus d, that gets you x. D plus x minus d is x. Well, the minus is here. The minus is indeed there. And then you go with it. trying to make some sense out of it, guys, to be honest with you. Okay, 0L. Yeah, everything looks right. Everything sure looks right. I think I think it's, as Yogi Berra once said, the great New York Yankees catcher, it's deja vu all over again, right? So let's see what we got here. You've got D times, you can take a D out of there, LND minus LN, the quantity, capital L plus D, LND minus LN, the quantity, LND minus LN, the quantity, capital L plus D, is LN D L plus D. Okay. Yeah, this is spot on, unless so I can't see that where it could not be spot on. That works. This works. Yeah, I'm agreeing with my notes. I'm agreeing with what I wrote some time ago. So this is right. This is good. This will work. You can plug in all the appropriate values that we had earlier written into here, and it'll get you there. This is right. This is completely right. Yeah, it's as simple as that. If you take this, and flip it upside down, then you have to have it. Well, look, let's just get something straight. This kind of explains a lot of what happened, and the mistake is completely mine. But it's resolved. I mean, so we have what we need. Look, let's say something here that maybe makes some sense. Ln of this, and this is the right answer for our purposes. This is the right answer. Period. You're here. You got this. This up here in the green, all in the green. That's your answer. That's your answer. Just plug in the values of what they gave you C to be, what you know 4 is, what you know pi is, what you know epsilon naught is, what you know that capital L is, what you know that D is, and just evaluate this, grind it out, and you got the right answer and you're done. For the record, and I have this, and what I'm about to show you I have in the notes. If you write this, are you believing me when I say to you that right there is the same as flipping this whole thing upside down and then taking it to the -1. Well, if I get the reciprocal of this thing, which is that, and then I get the reciprocal of that, don't I get back to this? Let's say it again. Is this guy right here put underneath 1 is 1 over all this, 1 on top of all this, does it flip and get you that? The reciprocal of this gets you that. Yeah, and the logarithm of something exponentiated is the exponent and yeah, it's something, so the reciprocal of this is indeed here. Okay. So this guy right here is the same as its reciprocal here, get the reciprocal of the, if you get the reciprocal of the reciprocal, you get back to where you started. The reciprocal of this is what you originally had. The ln of something to an exponent is the exponent times the ln of the thing that's there. Wait a minute. Isn't that the same? D goes into D one time. And L over D is this. This right here, you guys, that right there is equal to this. And this is what I have in the notes, guys. So I just wanted to kind of come back. I just wasn't agreeing. I didn't like what was going on. Well, I didn't like what was going on because I made a mistake in what I was writing on the board. The notes were right, and when you saw the notes would contradict what you're seeing on film. So I corrected it. I mean, the notes were indeed right. You can write it like that. If this guy right here, if all that is really the same as this, okay, you can always, like I said, you can always back up the film, guys. So, L, yeah, that's a negative. Plus a negative or minus D ln 1 plus L over D. Okay, well, I guess you could say it's minus D ln, the quantity, 1 plus capital L over D is the same as plus a negative D ln, the quantity, 1 plus capital L over D. All right, it's both reassuring and frustrating. It's reassuring that my original notes were correct. This is all correct. I mean, you can write it like this. Or you can write it like this. It means the same thing. It means the exact same thing. Plug into either one, guys. You should be okay to get there. When we grind this whole thing out, according to the answer key in the book, and to what degree of accuracy we're going to go here, they're more cognizant, they're more particular about the significant figures than I typically am. There's nothing wrong with that. On their part, it's a very good thing, but and there it is. When you grind it out, you'll get that. I do not know where I made the mistake originally, and then I guess I'll see it when I look at the film. But just make sure you're always looking at these films all the way through, because sometimes things happen and we have to correct something. It's not easy to edit sometimes right in the middle of an entire presentation, but we caught it. I mean, it took us off track a little bit, but we caught it nonetheless. The notes are completely correct. The notes that are going to be scrolling for you at the end of this video are completely correct. Go with that, and also just see the corrections and see what happened here. Somewhere I probably put a D in a place where I should have had an X. Something like that might have precipitated an issue like that here. Things happen. Anyway, everything's corrected up here, and the notes are correct that you have right here. I do appreciate your time, and take care. We'll talk to you soon.